Welcome to the DIY Honda Garage channel. The DTC P0141 indicates a malfunction in the heater circuit of the secondary heated oxygen sensor, HO2S, specifically sensor 2. This sensor is integral in monitoring the exhaust gases from the engine to ensure optimal fuel efficiency and reduced emissions. It operates by measuring the amount of oxygen present in the exhaust gases after they pass through the catalytic converter. The heater component within this sensor warms it up quickly, allowing it to function effectively even during cold start conditions. The location of this sensor is usually downstream from the catalytic converter, often near the exhaust pipe, and it connects to the engine control module, ECM, or powertrain control module, PCM, via a 4-pin connector. In the event the DTC P0141 is triggered, it is crucial to follow appropriate troubleshooting steps to identify the exact cause and facilitate necessary repairs. DTC P0141 signifies a heater circuit malfunction in the secondary heated oxygen sensor 2. This sensor plays a crucial role in the vehicle's emissions control system. It is strategically placed downstream of the catalytic converter, measuring the oxygen levels in the exhaust gases to provide data to the engine control module. The heater in this sensor allows it to reach operational temperature quickly, enhancing its accuracy in varied driving conditions. The failure of this heater can lead to inefficient engine performance and increased emissions, hence why troubleshooting this issue promptly is essential. Understanding how this sensor interacts with other components can assist technicians in effectively diagnosing the problem. Several potential causes can lead to DTC P0141 being triggered. One common cause is shorted wiring, particularly in the IG1 SO2, IG1 main, IG1 ACG line, which can inhibit proper electrical function. A faulty secondary HO2S sensor itself may also lead to incorrect readings or no readings at all, jiggering the code. Additionally, if the powertrain control module, PCM, software is outdated or corrupted, it may misinterpret signals from the oxygen sensor, leading to a false fault code. Each of these scenarios must be carefully evaluated, as they can each negatively impact the performance and compliance of the vehicle's emission system. Proper diagnosis will involve systematic testing of wires, sensors, and software. When DTC P0141 is active, several symptoms may become evident. The most noticeable indication is often an illuminated check engine light on the dashboard, alerting the driver to a potential issue. Furthermore, drivers may notice a drop in fuel economy due to improper air-fuel mixture adjustments caused by inaccurate sensor readings. This could also lead to higher emissions levels, as the engine's running parameters are altered to accommodate supposedly faulty information. In some cases, there may be noticeable changes in engine performance, such as rough idling, hesitation during acceleration, or poor throttle response. Recognizing these symptoms can be crucial for timely intervention and repair. To begin troubleshooting DTC P0141, start by turning the vehicle ignition to the on mode without starting the engine. This initial step powers the vehicle systems and allows for testing. Next, use the HDS or Honda Diagnostic System to clear any existing diagnostic trouble codes. Once cleared, start the engine and let it idle, which allows the vehicle's modules to generate new data based on the current operating conditions. After a few moments, check for any new pending or confirmed DTCs using the HDS again. If DTC P0141 appears, it indicates that the failure is currently present and warrants further investigation. If not, intermittent failure may occur, necessitating checks for poor connections, especially around the secondary HO2S sensor and the PCM. For troubleshooting step 2, begin by turning the vehicle to the off mode to ensure safety while performing the next actions. Check fuse number C30, which is a 10A fuse located in the under-fuse relay box. This fuse is essential for the operation of the ignition wiring associated with the secondary HO2S circuit. If the fuse is intact, it indicates that the IG1 SO2, IG1 main, IG1 ACG wire is not shorted and allows for progression to step 3. Conversely, if the fuse is blown, a short in the IG1 wires between the secondary HO2S and the fuse will need to be repaired, and the blown fuse must be replaced. This specific check is critical, as a blown fuse directly impacts the heater functionality of the sensor. In troubleshooting step 3, disconnect the secondary HO2S sensor 2 4P connector to perform resistance measurements safely. With the vehicle in the off-lock mode, measure the resistance between specific terminals of the 4P connector at the sensor side. Specifically, you should measure from test point 1, terminal number 3, to test point 2, terminal number 4. The expected resistance value should fall between 5.4 and 7.3 ohms at room temperature. If the resistance value meets this criterion, it suggests that the heater is functioning correctly, allowing you to proceed to the next troubleshooting step. If the measurement deviates from this range, it indicates a malfunctioning heater in the secondary HO2S sensor, warranting its replacement. For troubleshooting step 4, continue by checking for continuity at the secondary HO2S sensor 2. Ensure that the vehicle remains in the off-lock mode and that the 4P connector is disconnected. The continuity test requires checking the connections at the sensor side to body ground, starting first with test point 1 and then test point 2. If continuity exists between these terminals and body ground, this usually indicates that the internal sensor circuits are functioning correctly. However, if continuity is not present, it recommends replacing the secondary HO2S sensor itself, as this failure suggests internal damage or an open circuit within the component. In troubleshooting step 5, turn the vehicle ignition to the on mode, ensuring the secondary HO2S 4P connector remains disconnected. You will measure the voltage between designated test points with the expectation of obtaining battery voltage. Specifically, connect your voltage measurement leads to test point 1, terminal number 3, and test point 2, terminal number 4 of the disconnected connector. If battery voltage is present, it indicates the wiring and connections leading up to the sensor are intact, prompting the technician to continue to step 6. If battery voltage is absent, this suggests an open circuit, which necessitates repairs in the wiring between the sensor and the fuse, as outlined in previous steps. For troubleshooting step 6, switch off the vehicle ignition to prevent any unintended electrical issues. Begin by jumping the SCS, System Connector Short, line using the HDS to facilitate troubleshooting. Disconnect the PCM, Powertrain Control Module Connector B51P, to isolate the circuit and measure continuity between test points. The continuity test focuses on checking from the PCM connector to the body ground. If continuity is verified, it indicates that the SO2HT wire is functioning correctly, and further steps are necessary to ensure the software on the PCM is up to date. Should continuity fail, it suggests a short in the SO2HT wire between the PCM and the secondary HO2S, requiring immediate repair. In troubleshooting step 7, you'll return to checking the integrity of the IG1 SO2, IG1 main, IG1 ACG wiring. With the vehicle on, measure the voltage between test points, specifically from terminal number 4 of the secondary HO2S connector to body ground. The presence of battery voltage confirms the integrity of the IG1 wiring, allowing for progression to Step 8. Conversely, if there is no battery voltage, it indicates a wiring open between the number 4 of the NECG connector, C30 fuse, and the secondary HO2S. This scenario requires immediate attention, necessitating repairs to rectify the open condition in wiring that may be preventing proper sensor operation. In the final troubleshooting step, repeat the continuity test focusing on the SO2HT line. Turn off the vehicle and complete the SCS jump using the HDS prior to disconnecting the PCM connector B51P. Measure continuity between test points correlating to the PCM and secondary HO2S 4P connector. A successful continuity reading would mean that the SO2HT wiring is intact. However, if continuity fails, it indicates an open circuit requiring repairs between the PCM and the secondary HO2S. If continuity passes, check whether the PCM software is the latest version. If not, update it. A confirmed update will conclude the troubleshooting if DTC P0141 disappears. But if it remains after a PCM swap, then replace the initial PCM. After completing the necessary repairs and replacements pertaining to DTC P0141, it is crucial to verify system functionality thoroughly. Start by clearing all diagnostic trouble codes using the Honda Diagnostic System, HDS. Following this, initiate a test drive under diverse driving conditions to ensure the vehicle operates smoothly without triggering any fault codes again. Monitor systems that involve the secondary HO2S for normal operation and check that fuel economy and emissions levels return to acceptable levels. This final verification step ensures that not only is the immediate problem resolved, but underlying or recurring issues do not reemerge. Preventive maintenance is essential to ensure the continued longevity of the vehicle and to avoid future issues related to DTC P0141. Regular inspections of the secondary HO2S sensor and associated wiring should be conducted to identify signs of wear, corrosion, or damage, which may lead to similar problems down the line. It's also vital to examine electrical connections for looseness or deterioration. Furthermore, ensuring the PCM software is up to date can prevent misinterpretations of sensor data, which may result in fault codes like P0141. Establishing a proactive maintenance schedule can help catch minor issues before they develop into larger, more costly repairs. In conclusion, DTC P0141 indicates a malfunction in the heater circuit of the secondary heated oxygen sensor, HO2S, which is crucial for optimal engine performance and emissions control. A well-structured troubleshooting process, as outlined, is vital in diagnosing the root cause effectively. This approach not only resolves the immediate issue, but also educates vehicle owners and technicians about the significance of regular inspections and preventive maintenance practices. Understanding the role of the secondary HO2S, recognizing symptoms of coding errors, and addressing wiring integrity will lead to overall enhanced vehicle operation. Staying ahead of potential issues through diligent vehicle care is key to maintaining the Honda HR-V's reliability. Please like and subscribe to the channel. See you next time.